We're good? Okay.
Introduce yourself.
Hi, I'm Carl. I'm the software scouting lead on Citrus Circuits.
I'm Richard McCann. I'm the scouting and strategy mentor with Citrus Circuits. Worked before.
Yeah. All right, so this is a brief outline of what we're going to go over today. So we're first going to start with the benefits of an electronic scouting system and why your team should have an electronic scouting system. Then we're going to talk about the process that we go through to create our own scouting system. Then we'll talk a little bit about the logistics of running a scouting system at competition and a little bit before. And then also the many lessons we've learned and the mistakes we've made. So hopefully you don't have to make those same mistakes. Then we'll go over the first time creating a system and our tips and how we advise going about that. And then we'll link to some resources for you to learn more.
So I'm going to talk a little bit about the benefits of scouting. Next slide. I think that first off that you recognize that FRC is an alliance-based competition, and there's real benefits to scouting for alliance mates, but not only for your pick list, but also for your strategy. We use it extensively in terms of strategy alliance for each of our individual matches. And that really seems to give us, we feel like it really gives us a very strong competitive edge. And then it also allows us to very quickly create pick lists. And in fact, Carl will talk about this a little bit more. We're able to update our pick lists on the fly with our scouting system. So it's a really important part of it. But the other aspect, which is an educational benefit, there is definitely a lot of elements of technology and engineering and mathematics that's involved in dealing with scouting systems, whether it's paper or electronic. And we find that those sorts of skills that are gained are really important. For example, I was working with one student using college linear algebra in order to develop our scouting system. Next slide. So in terms of the competitive benefits, of an electronic system, we have a scouting system. I carry it around on my phone. I mean, we are able to communicate with our drive team in almost real time in terms of communicating information from the field to our drive team. And that really enables us to develop very good strategies in qualification matches. They are constantly, as I said, getting updated information. We also find that it allows us to do more data collection because we are able to develop more intuitive data collection systems with an electronic data collection process. We're able to do accurate timing. So for example, we were able to accurately time how quickly robots were able to put cubes into the scale at certain points in the match. And even though you get more data, you can have a simpler system in terms of data input. And so Carl's going to talk about that some more later on. In terms of human error, it's actually less human error to use an electronic system that we found. It's much easier to fix errors if you find them. And it's better and easier for sorting draft picks. We are able, like I said, to sort our draft list on the fly on the second day of the match. We do our draft picks the night before the final competition, and the next day we're able to sort our draft list on our data viewer because it's electronic. We don't have to do it by hand. And finally, we're just able to update our alliance selection as we go along in that final day. Next.
And so this is an image of how we can use an electronic scouting system to collect more data with less complexity. And this is something we'll get into a little bit later.
And then there's the educational benefits, as I mentioned, about using an electronic system. As I mentioned, you develop mathematics and statistical skills. We typically, every year, are doing college-level statistics in terms of our analysis. We're able to do probability analysis of wins and losses in matches because we are able to gather this data quickly, electronically, and update it. You also use your programmers more effectively. You find that you have many more programmers, and to be honest, there's only so many programmers that you can use on your robot programming side. We can use an infinite number of programmers on our scouting system. I don't know, how many scouting programmers do we have?
18.
18. We could use more. We have more projects that they could do. 18 is not enough. In the mobile field, it's mobile computing field. on your smartphones, etc. That field is growing dramatically. That's a career path which needs more programmers, and we are developing those programmers. And there are more career training skills that you learn by doing programming. You get both the technical side and you get the soft skills of how to project manage, learn the industry language and the various standards that are used in the industry. And we find that this is really beneficial. We've had several students who have gone on to be interns at Apple and at Google and at Microsoft, even in high school. So this is the kinds of educational benefits that we see out of this line of pursuit.
And some of the other technical skills, in addition to learning industry standard languages, is being able to create an effective UI, gathering user feedback and going through the iterative process, and then also collaborating with others on code in a group environment where you work on the same code at the same time. And then that's also a soft skill, which leads us into the few other soft skills you get. Richard already mentioned project management, and that goes in hand with leadership. But all programmers also learn creative analytical thinking because of the nature of how programming works, and then also creative problem solving. Okay, so this next section is about how our team creates a scouting section. So it's not necessarily how your team should create a scouting section or scouting system, or the best way to create a scouting system, but it's how our team does it. And so before we start any development, there's 3 questions that we ask. Those are, what data do you scout for? What metrics do you calculate? And then how do you use that data? And so in order to answer these questions, there's a lot of strategy involved. And so in both in the metrics to measure your robots, and then how to display that data in a useful format, and in having a strong integration between your developers and your strategy team. The first part of strategy that's involved in answering these questions is game strategy. And so what you're looking for in a first and second pick partner, and also what you're looking to measure about your alliance partners in quals and elims, or sorry, in quals, and also your opponents in quals, determines what data that you scout for. And so first you have to figure out, what do I want in a first pick? What do I want in a second pick? And what metrics can I use to measure that? The second part is designing a strategic UI. And so UI stands for user interface. And so when you're designing a UI, you don't want to just design it based on your data. You want to design it for the user. And so on your scouting app where you're collecting data, that means simplicity. The simpler your app is to use, the less time scouts spend looking at your tablet, which means the more time they spend looking at the field, which directly correlates to how accurate their data is. And something we learned the past year is that overcomplicating your scouting app can lead to much less accurate data because scouts are spending much less time looking at the field. So in order to make it data collection simple, there's 2 components to that. And so that's designing your UI to be intuitive, which means placing buttons where the user would expect them to be. And then the second part of that is allowing for efficient input. And you can determine how efficient input is based on how long it takes the user to input that action, or also how many taps or clicks it takes them. And so actions that are more commonly inputted should be less clicks, less taps, and less time, as opposed to actions that may not happen as often, such as climbing. On the data display side, it's really about relevance. It's what information is relevant to the user of the app. So whether that's in qual strategy or during the pick list meeting, what data is the most important to them, and how can you display that data the most effectively? And so that means displaying the more commonly used data points up higher, and then also displaying graphs for some of the other data points. And so display is really focused about relevance and how can you design the app so that the app is as quick to use as possible for the user. And the quicker the app is to use, that means the more often the user will use it, which means you'll be able to reap more benefits of having an electronic scouting system. If an app is clunky and hard to use, your users aren't going to end up using it, and so you're not going to get those same advantages that you get with the electronic scouting system just because your UI wasn't designed strategically. And so because of all this strategy, there's a need for a strong integration between your developers and your strategy team. And so that starts with a concrete knowledge of the game manual. So that's something on our team we require for every single member, but it's especially important for your developers to understand all the rules. Otherwise, there's no way they're going to be able to understand strategy. And so we also heavily encourage participation in strategy development from our developers, because there's often times where you have to make a decision about your scouting system, and you can't ask your strategy team for every small decision. And so what often ends up happening is that your development team makes some of those smaller decisions that can affect what data you get outputted. And so it's really important that your developers participate in strategy development so they understand the strategy and they design the apps with that in mind. And then also one more thing, it's fairly obvious, but I think we find it pretty important to point out, is that you should be consulting your strategy team. The data that you collect is really for your strategy team. And so if you're not consulting with them, you're not going to get the best data possible, which means you're not going to get as much out of your scouting system. So in order to do that, you need to consult your strategy team and see what metrics are actually useful for them, what data do they want. So that brings us to our first question, which is, what data do you scout for? And so there's two types of data that you can scout for. That's quantitative, which is numbers and things that are objective, and qualitative, which are more subjective metrics. And so the advantages of quantitative data is that it's comparable. That means you can look at two different teams. You can look at quantitative metrics and see, oh, this team is better than this team. You can objectively say that. And so you can also use it in calculations. And so that means you can use it to rank teams. You can use it in composite scores, where you take multiple data points to create one composite score. And then you can also use it in match predictions. And so quantitative has all these advantages. And so you want to use it whenever you can. However, there's some instances where you can't use quantitative data. And so you have to use qualitative data. And so this is used for subjective metrics, like defense or driving. And so what we found is really useful is trying to attribute quantitative metrics to those qualitative data points. And so what we do is, to measure the driving ability of a robot, is that we have our Super Scouting app, which is for subjective data. They rank the teams compared to one another. And so this is an ordinal ranking system where you're comparing one team to another team. So two teams in one match cannot have the same ranking. A lot of teams use a cardinal ranking system, where you rank a team, say, from 1 to 10 based on all the other robots across all their matches in the entire competition. And so you could, say, have two teams with the same score. The problem with comparing against the entire competition is it's a lot harder to do, which leads to less accurate data. And then you also have the bias of seeing maybe a better robot in one match, and so you rank another robot lower. And so what we do is we use comparisons. So you're only comparing to the other two robots on the lines in that match, and you rank which one's better than the other. And so even though you're not playing against every other robot, we can use the transitive property, because if we know if robot A is better than robot B in one match, and in another match robot B is better than robot C, then we know that robot A is better than robot C. And so doing this in a smaller configuration where we're only comparing to two other teams allows us to get much more accurate comparisons, which allows us to get much more accurate data out of those comparisons and get accurate metrics for subjective data like driving or defense. OK, that brings us to our second question, which is, what metrics do you calculate? And so you have your basic averages or percentages, like the average number of scale cubes placed in a match, or the percent reliability, how often the robot is incapacitated in the matches. And then you also have your red flags, like if a robot didn't show up to half their matches, or if they weren't able to drive, or their auto didn't work in a lot of their matches. And so those are your more simpler data calculations. From there, you also have more advanced scores, and one of those is composites. And so a composite score takes into account multiple different data points in order to create that score. And so our team uses composites for our driving ability, where we take into account speed, defense, and agility, which are all the comparisons I mentioned earlier. And so we're able to get a more accurate representation of the driving overall, since we're not measuring the driving directly, but we're measuring different aspects of their driving and then creating a composite score based on that. Another composite that we use is our first and second pick ratings. And so when we're creating our pick list, we have a list of teams, and we go down the list, and we compare each team to the ones above it, and we see if it should be moved up. And so the first pick and second pick rankings are designed to give us a basic list to start with, so that we have to move less teams overall. And so this really increases efficiency during the draft night process where we're creating our pick list if the list is already in somewhat of an order. And so the way these composite scores work is that it takes into account multiple data points, and each of them has a different weighting. So for example, scale cubes might have a higher weighting than exchange or switch cubes. And so from these composites, after our first competition, we reevaluate these weightings in order to create we try to tweak the weightings so that our generated pick list that we start with is as close to our actual pick list as possible. And we tweak this after each competition in order to get a more useful first pick composite, which saves us more time in draft night. Another data point we calculate is our last 4 matches. And so the intention behind this is that some teams start off performing poorly at a competition, but then they get better towards their last few matches. And so the last 4 matches is basically, it takes into account the last 4 matches of a team. And so you have last 4 match data points for every single normal data point, like your average scale cubes, but you just have last 4 matches for each of those. And so this allows you to see when a team is dramatically improved, but it doesn't show up in their normal averages. And then some of the more advanced metrics that can be really useful. For example, this year we had a metric where we looked at the number of cubes a robot was able to place at 110 seconds or 100 seconds remaining in the match. And so this accounted both auto and tele-op cubes. And so what we noticed, and Richard actually came up with this idea, what we noticed is that the scale is often 1 in the first few seconds of the match where you have 110 or 100 seconds remaining. And so we wanted to see what teams were able to place cubes fast at the beginning so that they could gain that advantage and then end up winning the match. And one other aspect of this is that during the match, you often don't have a team who's placing on the scale the entire match as fast as they can. Sometimes they go drive to play defense, or they play defense on, or they're going to score somewhere else. And so by looking at the first few seconds of a match, you're able to see robots performing at their fastest cycle times, and then you can take averages based on that. And so this allowed us to get much more comparable data and get a much more accurate representation of what that robot was actually capable of. And so that brings us to our third question. So once you scout for all this data and you create all these metrics, how do you use that data? And so for your qualification matches, you can use it to analyze the ability, strengths, and weaknesses of both your alliance partners and opponents. And so this allows you to tailor your strategy to your alliance partners' strengths. And so you can have, because you know what their individual strengths are, what they're better at, and then you can tailor it to that in order to get a better performance in that match. It's also really useful when planning defense, because you can look at which robot do I want to play defense on, which is going to give me the most advantage if I do play defense on. And so you can look at your scouting data and you can say, oh, this robot's better than this other robot at what we're trying to defend against. And so we're going to defend against that robot. And it also allows you to look at different alliance combinations and what an alliance's strengths are combined. And then you can also use this data to predict the outcome of matches, which can help you when looking at the seedings and trying to figure out who's going to seed where. And then the second part of using our data is we also use it for our pick list creation. And so like I mentioned earlier, we use comparisons where we go through and we compare each team to the one above it. And so all the data we collect allows us to make those comparisons and determine and rank the teams in order. And then after we create our pick list during the second day of competition, we update our pick list as the matches continue and we see teams either improve or worsen. And so we can look at the scouting data and be comfortable with moving teams around quite frequently. And then there's also a second part to using data. It's how do you display that? And so this image here is of our spreadsheet that we use for draft night. It's on Google Sheets. And then this image up here is also a graph generated from that. And so basically, this is what I mentioned before. You have each of the teams listed here. And then you have all these data points and all these columns, which you can look at for each individual team, like the number of cubes they placed in the scale, or how reliable they are in a match, what their driving ability is, or even the size of their robot. And then we also can compare robots. And so you can see up in the graph, you can compare up to 4 teams on a single data point. And so this allows you to make easy decisions when you're looking at different teams and you want to see which one's better than another. We also have a graph where you can compare 2 combinations of 2 teams. And so you can look at the combined metrics and see how do those teams perform when they're together. And then you can see here on the bottom right side, we have our viewer app. And so this is our Android viewer app. And you can see here it has a bar graph comparing teams' performance on a single data point across all their matches. And then here is just an overview of the team, giving information about their matches, team number, and then some of the more valuable metrics. So this next section is about how to go about creating a scouting system for the first time. And we really recommend not creating a scouting system nearly as complicated as ours. Starting out simple allows you to scale it in the future. And it's not as hard as it might seem to create a scouting system for the first time. So the first step is picking what platform you're going to use. And so oftentimes, teams have developers who may have experience with a specific language. And so when they go to create an electronic scouting system, they create it in the platforms that use those languages. And this is a behavior we really discourage because picking a platform determines the capabilities of your scouting system. And different platforms have significant advantages over one another depending on what your use case is. And so picking a platform based on the personal skill of your developers can really hinder you in the future, and even in the short term. Because you're picking the platform, you might not get the advantages. You might miss out on a much better platform. And so while it may give you a small gain in the beginning because they have experience with it and they're able to develop quicker initially, you lose a lot in the long term or even the near short term because picking a platform based on skill alone can really hinder the performance of your scouting system. And so for mobile development, there's two main platforms. Those are Android and iOS. And so Android is significantly cheaper to develop for than iOS because developing for iOS requires a Mac or a MacBook. And those are expensive devices as opposed to Android, which you can run on almost any computer. Additionally, developing for iOS devices costs $100 a year, as opposed to Android, where you can do it for free, or if you want to distribute through the Play Store, it's $25 for life. And so starting out with Android can mean it's much cheaper for you to purchase the hardware that you need to run those apps, and also to purchase the hardware you need to develop the apps, and also to develop the apps. And so a question we bring to this between deciding Android and iOS is why not both? There are cross-platform solutions that exist, like Flutter or React Native. And so what these allow you to do is code in a single code base and then deploy to two different platforms. And so Flutter is something our team experimented with this year for our simple Scout QR app, which we'll show a little bit later. And what we did is we were able to code in a single code base and then deploy native code to both Android and iOS. So we got native-like performance, but with a single code base. And then progressive web apps. How many of you have heard of progressive web apps? Awesome, more than I thought. That's like 5 of you. And so basically what progressive web apps are designed to be like a website that looks and feels like a mobile application and that you can actually download onto your phone just like a mobile application. And so they've made significant advances in the past few years, including the capability to add it to your home screen just like a normal app, and also to have it work offline. And the advantages of this is that you're able to update your, not only do you have a single code base for every platform for Android and iOS and desktop computers, but you also are able to update your app immediately during competition. And so when the user opens your app, it reloads the app. And so if you have any bugs that you need to fix, you can fix them. And then the next time the user opens the app, it downloads the new version of the app with those fixes. As opposed to a native platform where, say, if you were looking at your viewer app and there was a bug that causes it to crash, you have to go track down every single person and their device to download the app onto their phone. And so web apps provide a significant advantage in both deployment and also providing a single code base. And so we haven't used web apps at all, but it's something we're definitely looking into and we're experimenting with for the coming season. And then also for a more simple scouting system and a very cheap scouting system, you can use Google Forms and Google Sheets. Google Forms work on basically any smartphone or computer, and you can just have a simple form which outputs directly to a spreadsheet. And that spreadsheet can do simple calculations or even more complex calculations. And then you can just view that on a phone like a Google Sheets. Yeah.
Another thing that my team has been using for a couple of years is AppSheet, which is basically an add-on to Google Sheets, where you can make an app that it's like a data management app system where you can just like make an entry and like, you know, as you're watching the game, make the entries, and then it'll just upload it straight to the sheet. And that's what we've used, and it's worked pretty well.
Awesome. And so there's also a couple more advantages with Google Forms and Google Sheets. You don't need nearly as much programming experience. If you want to do some of the more advanced calculations, it requires a little bit of programming, but not nearly to the same degree as it would to create a native application. With that, you also have a lot of limitations with this. As at least a Google Forms, you can't control the UI as much, and you also can't do as it also doesn't work offline. And then so the second part is, what hardware do you want to use? And so for your data collection app, for us, that's our scouting app, we really recommend purchasing hardware if it's possible for your team. And so what this does is it allows you to limit your collection apps to one platform and one device. And so you only have to program for one screen size, for one type of device. And so you don't have to create different platform apps. And so you can use a single code base, and it's all on the same device. And then additionally, with purchasing hardware, you also avoid the logistical mess of having to loan equipment. And so often, if you try to loan equipment, you often get a bunch of different devices, which you have to test your app on every single one of those different devices. And then you also have to make sure the loan equipment stays in good condition, that some people have restrictions, so maybe it can't go to this competition, but it can only go to this one. And so it's really a logistical nightmare to try to manage different loaned equipment. And so if possible, we really recommend purchasing hardware for the collection side of things. However, on the viewing side, since that often uses the phone of the user, we don't recommend purchasing hardware. Because purchasing hardware would mean distributing devices to multiple people who are not in one central location, unlike your scouting team. And then also it requires users to carry on multiple devices, and it also leads to logistical mess. And so for the viewing app, we recommend using the phone of the user, and that's what we use. And so in doing this, we really recommend, if possible, trying not to limit yourself to one platform like Android or iOS. And limiting yourself to one platform can, even if you have, say, everyone who's working on your strategy team using one platform now, in the future that's likely to change. And you really don't want to limit yourself in terms of what people can contribute to your strategy team based on the platform. And so we really recommend trying not to limit yourself to one platform for the viewing app. So the next section is a little bit about the logistics of how we run our scouting system, and then also the lessons learned and the mistakes we've made that we're telling you in hopes that you won't have to make those same mistakes. And so before competitions, we find it's really important to train your scouts how to use the app. And so what we do is we scout match videos. We have 1 or 2 sessions before each competition, which are around 3 to 4 hours each. And so we have scouts scout videos that entire time. They learn how to use the scouting app and then all the different possible combinations of robots they can get. One thing we recommend is picking robots that are difficult to scout. So don't just pick a match with 6 robots in it and then have them scout all those robots, because you might have disabled robots or robots that don't do a lot in that match. And so you're wasting your scouts' time by having them scout a robot that doesn't move the entire time. And so we recommend looking at the videos beforehand, picking out robots that are difficult to scout, but also that have variety. So not just scale robots, but also the different types of robots, but robots that are more difficult to scout, as opposed to robots that don't do anything in an entire match. And also one more note, if you're competing at a week 1 event, what we do is we watch week 0 videos. And so this is especially important then, because a lot of robots might not be functional during those matches. And so you want to focus on the more competitive teams. And then during competition, we schedule our scouts. And so it's very important to rotate your scouts and to provide breaks, because scouting is extremely tedious. As any of you who have scouted before, you probably know how tedious it is to sit in the stands for hours and watch matches and collect data. And so without breaks, this is even more tedious. And so it's essential to provide breaks to your scouts, to make sure they're fresh, they're able to think, and they're able to stay awake.
I want to make one point too, is that you need to tell your scouts they're important. I always forget this every year, and sometimes we get a little grumbling from our scouts, and they're one part of the 3 legs of our success of our team. And so scouting is really critical, and they need to know that they're very important. So please reinforce that with your scouts.
And I just want to reemphasize that point. Yeah, scouting is very essential to the competitive success of our team, and that's something we're going to get into a little bit later and how important it's been to us. Another lesson we learned, so some of the lessons we learned are testing. So after each feature is developed, it needs to be tested by multiple people. And so when you're testing it, make sure you're not having the person who created those features test the app, because they're often to miss something. And then also make sure you're testing every single possible scenario and every aspect of the app, not just a couple scenarios. And then also what we do is we run at least 2 full systems tests before each competition. And so this involves every app working together with our database. And so we scout actual match videos, and we can see how our system runs together. And so this often uncovers a lot of potential errors or bugs that we wouldn't be able to find otherwise. Be careful, though. Don't use this in place for testing. Each feature needs to be tested after it's created thoroughly. That's not what the purpose of full system tests are. Full system tests allow you to find bugs or flaws that you wouldn't otherwise able to be find because you can't simulate competition perfectly. And then also Scout training can serve as a field test for your apps, but be careful of this, because if your apps aren't functional enough for your scouts to scout, you just wasted a bunch of time that they could have spent scouting, and now they can't watch any match videos because your scouting system's broken. And so we recommend having full system tests and making sure your scouting app will at least be able to be used by testing it beforehand. Another lesson we learned, and this was from last year especially, was the data transfer. And so as you know, Wi-Fi is not allowed at first competitions. And so for the past few years of our scouting system, we've used Bluetooth internet sharing to send data. And so what this does is it takes a device like a tablet or a laptop, and it creates a Bluetooth connection that shares internet access to those devices. And so at Utah, which was our first competition last year, we found that there was a lot of Bluetooth interference. With the growing number of connected devices like smartphones or smartwatches, and also Wi-Fi interference from the robots, which run on the same spectrum as Bluetooth, we noticed there was way too much interference, and we had a very unreliable data transfer system. And so what ended up happening is that our data transfer system did not work, and we had to rush outside, take the tablets, connect them to Wi-Fi during lunch, and then upload data then. And so from there, yeah.
Well, it's just like host a server and upload data to that server through like cellular.
Yeah, we're gonna get into that. But how do you we have 18 different scouting tablets, so we can't connect each one to a cellular connection because that would cost a lot of money.
So he's going to tell you how we did it. We actually did cellular, and we did it this way, which is.
Yeah, I'll get into that in a second. And so our sub team that develops these apps is in a constant, our entire team actually, but the sub team especially is in a constant mindset of continual improvement. And so we weren't satisfied with our data transfer system at Utah. So we completely scrapped it and then created a new transfer system that used Bluetooth file transfer, which allowed us to only initiate connections when the data was being sent. And so we found that the interference was much less because we didn't have 18 connections interfering with one another. And so this worked a lot better. And so we used this at Sacramento. However, there were still some limitations to this. We often had data wouldn't send, or scouts would take their tablets and then lean into the computers that had the Bluetooth connectors on them. And then they'd be waiting there, sticking their arm out for 30 seconds to a minute. And so they were fine with it, and they saw a huge improvement over Utah. But we saw something that could be improved. And so in the 2 weeks between Sacramento and the Central Valley Regional, we scrapped that entire system again and recoded a new system from scratch. And this time we used a QR code system, where basically there's an app like this one on the scouts' phones that has a QR code to transfer data. And so on the tablet, they scan this QR code, and then the phone updates to our database. And so the phone is basically a middleman between the tablet and the database, where it receives data from the database and then displays in a QR code and then sends it to the tablet. And then the tablet also displays a QR code that the phone can scan, which then uploads to the database. And so we found this method of data transfer to be extremely reliable. We had no problems with that at Sacramento or at Central Valley Regional or at Champs, and we found it to be much better than the system we had before. And we actually got this idea from a team at the Utah Regional, Team 2468. And they came up to us and they showed us their scouting system and how they use QR codes. And so we took that idea and then we leveraged it and added on to it and applied it to our own system in order to make this system.
So, and And you will hear from Mike Corsetto in his talk. One of our golden rules is steal from the best, invent the rest. So we were getting we get lots of ideas from other teams and then just and tweak those ideas.
Another lesson we learned is overcomplication. And so last year with our scouting app, we really overcomplicated it. We tried to scout every single data point possible. And in doing so, we significantly impacted our accuracy. And so an example of this, so here on the left is our scouting system from last year. And so we collected intake information about if the robot intaked from a portal, if it intaked from the ground from a portal, if it intake from the pyramid, if it intaked from a higher level in the pyramid, or if it intaked from the exchange, or from one of the 12 different positions of the cubes next to the switches in the platform zone. And so we collected and in addition to that, we also collected normal intake. And so we collected all this different kinds of data about intake. But what we found is that we didn't use any of that data. We never even looked at intake data in creating our pick lists or in our call strategy. And so we were adding all this complication, and we didn't gain anything out of it. And so that's just one example of how we overcomplicated our scout app last year. And what we found is that it significantly impacts the accuracy of the scouts. Because we had so many different types of intakes, the scouts were confused about which intake type was which. And so when they saw an intake happen, they're like, what type is that? And then they had to try to find it on our UI. Where do you input that intake? And so this complication made the scouts a lot less accurate because they spent so much more time looking at the tablet screen or trying to figure out what type of intake it was. And so they were spending less time looking at the field, and so our data was much less accurate. And so what we've learned from this is that it's important to prioritize a simple UI for scouts, not to prioritize trying to collect every single data point possible. You should not focus on trying to collect all the data that you can, but on creating a simple UI for your scouts so that your data is as accurate as possible. And so you can see here on the right is how we changed our scouting system. And so we weren't happy. And again, with that mindset of continuous improvement on our sub-team, we decided to scrap our scouting app and recode in the off-season to see how it could have been done better. And so here you can see on the right, that's our new development that we're currently working on. And instead of having all these different types of intakes, the scout simply clicks on one of these 4 different colored zones to input an intake. And so it's one tap, and it's very simplistic, and it makes sense. And so we also applied this to other aspects of our scouting system. But you can see it's much simpler to collect intake, but you're also still getting that data about each of those different positions.
And which teams did we get this idea from?
So we saw 3005 using a system like this at Champs, where they
happened to look over their shoulder.
Where they had a bunch of different buttons around a map, and so they tapped on a button for a specific action, and then tapped where it occurred. And then we also saw 1619 using a map-based system on a little bit of a different, simpler scale, where they didn't have so many action buttons, but they had intake or placement on the map, and then also had a few auxiliary buttons for like incapacitated or climbing.
And then we also have been working with them, helping them develop their scouting system on other aspects. So we've worked cooperatively on this. And so we found on our team that electronic scouting system is an extreme advantage in competition. And as Richard mentioned earlier, it's one of the 3 pillars of our team's competitive success. So those 3 include our qualification match strategy and our drive coaching, our robot itself, and then our scouting. And so we found that 2013 is probably the best example of this, but we found our electronic scouting system to be of extreme advantage in competition. And so at the Central Valley Regional in 2013, we declined 1458, which was a 3rd seeded team, while we were the 6th seed, because we knew we could pick up 840, which was a full court shooter, and that we could get 295, which was one of the best driving teams. And so other teams didn't see these teams on their radar. And so we looked, and because of our data, we were able to tell that these teams were hidden gems and that we could pick them even if we declined 1458. So this gave us the confidence to decline 1458 and then go on to win the Central Valley Regional. And 2013 was actually the first year we used an electronic scouting system. So it goes to the point earlier where it doesn't take a super complicated scouting system in order to gain these huge competitive advantages.
And then at Champs in 2013, we used the scouting system for a scorch strategy. We used it to see what teams we wanted to invite and then scorch, and what teams. We used it to determine what teams we wanted to scorch. And so this allowed us to do our scorch on 2013, which allowed us to win our division in 2013. And also for our alliances in that division, we found 862, which was a really good team, but had dropped really low in the rankings. And our data showed us that they were a really good pick. And we were extremely surprised that they weren't picked in the first round. And so we were able to pick up this really good team because our scouting system showed us data that no one else had. And so Richard mentioned this earlier, but that with an electronic scouting system, some of the other competitive benefits you gain is that you're able to collect more data. And so that includes things like accurate timing, which wouldn't be possible without an electronic scouting system. There's just some types of data that you cannot collect even with a very sophisticated paper scouting system. With an electronic scouting system, you only have to have the scout enable the timer once, and then you can get accurate timing for each individual action. As opposed to if you wanted to get that same data with paper, you'd have to have the scouts record the time on the paper for every single action, which is much more complicated than simply tapping and having the electronic system record that time for you. And then you're also able to collect more data with less complexity. And so I mentioned this earlier, but we were able to collect, last year, we didn't leverage this advantage of an electronic scouting system as best as we could because we had different types of intakes. But if you wanted to do all those different types of intakes on paper, you would have to have names for each of those systems, and you'd have to have scouts memorize those names, which adds a huge layer of complexity, which has the same problems I mentioned earlier with overcomplicating your scouting system. However, with an electronic scouting system, you're able to control the UI, and so you're able to make it simpler, but you can still collect more data. For example, here, we're still able to collect intake locations like in 4 different zones, but it's very simple. It's just one tap in one of those locations, and it's very intuitive and easy to use. However, if you wanted to do something like this on paper, you would have to assign numbers to each of the zones, like zone 1, 2, 3, and 4, and then you have to have scouts memorize which zones are which, and then record those numbers, as opposed to an electronic scouting system where you have complete control over your user interface, and so you're able to design for simplicity while collecting more data. And so one other aspect of this is the various climb types this year. And so there are a lot of possibilities this year in terms of robots climbing by themselves, or climbing alongside another robot, or lifting another robot, or lifting 2 other robots, or lifting a robot but not lifting itself. And so when you factor in all these different combinations of successes and failures, where say it was trying to lift 2 robots but only lifted 1, or it failed on climbing. And so when you factor in all these different success and fail possibilities, you get a lot of different combinations. And if you want to scout all these different types, you have to assign names to each of those. Like lifting another robot would be assisted lift or active lift, or a robot driving on a ramp is different than a robot climbing onto the bar of another robot. And so you have to assign all this terminology, which you have to have your scouts memorize, which adds a huge layer of complexity. And so this is something that we actually ended up doing because we didn't fully leverage the advantages of an electronic scouting system. And so we had the scouts memorize these different names for climb types. And so what we found was that scouts forgot what climb types were which. And they got really confused by the climb data. And so we weren't able to get any accurate climb data. However, what we could have done, and that we didn't realize, was that since we can control the UI, we can create a better experience where you can just ask them a series of 3 or 4 yes or no questions to create in like a flowchart sort of manner to find out that same data with much more simplicity. You simply have 4 questions like, did the robot climb by itself? And you have these simple yes or no questions that are intuitive and make sense, which is only possible with an electronic scouting system. And so this is much simpler than having scouts memorize all these different possible combinations, because you can do that all for them with your electronic scouting system. And then I also mentioned that you're able to control your UI. And so the advantages that this gives you is that you can create simpler interfaces, which, as I mentioned earlier, simplicity is directly correlated with accuracy. And so since you're able to control the UI, you can make it as simple as possible, which means you get more accurate data. In addition to this, you can do things that paper can't do. Like you can warn a scout of missing or invalid data. Like they forgot to input the starting position of the robot, or they put 2 intakes in a row. And this simply isn't possible with non-electronic scouting because you cannot do that sort of type of thing. But it's easy to do, and it's intuitive with an electronic scouting system. And so this, again, leads to more accurate data since you're able to catch those potential errors. And then in addition to that, you can easily edit input. So here on our new version of our scouting app, we have an undo button. And so this is something you can't really do with paper because it's something that it's very easy to use with an electronic scouting system. The undo button is very intuitive. Everyone's used it on like a Microsoft Word or Google Docs, and everyone knows what undo does. And it's very intuitive, and it's ingrained into how we think. And so having an undo button makes it possible for, if your scouts input data incorrectly, they can just simply click one button. It takes them 1/10 of a second to undo something, as opposed to having to like erase something or modify some value. In addition to this, it also enables predictive scouting. And so this is something that we've noticed that some of our scouts do with our electronic scouting system, where they look at a robot, what a robot's about to do, and they record the action a couple seconds before it actually occurs, or just about a second before it actually occurs. And so the undo button makes this possible. You can undo something if they end up dropping the cube at the last second, or they look like they're going to place it perfectly, but then they drop it or it tips and falls off. And so as opposed to normal scouting, where you would have to wait, you would have to see, oh, it looks a little tippy, so you have to wait a couple seconds to see if it will fall off. And the robot's already driving away and doing another action. However, with an undo button, you can use predictive scouting, and you can say, oh, I'm 90% sure they're going to press it, but I know I'm confident in recording it earlier because I know I'll be able to undo it if they end up not doing that. It also allows you to edit your data. And so you can see we have an edit button up there. And so that allows you, say you recorded data at the right time, but you recorded the wrong type or the wrong value. Instead of having to undo it and then input a new type of data, which have the wrong timing, you can just simply edit it, and it will keep all the other values except the one that you inputted incorrectly. And so this simply isn't possible without an electronic scouting system. Another one of the lessons we learned is the value of debriefs. And this is something our entire team does, but it's a little bit different and a little bit more specialized in our specific subteam. And so debriefs involve eliciting feedback from your users. So that doesn't mean waiting for them to complain about the app. It means actively going out and seeing what do they think of the app. What could be improved? What are they not even thinking of that we can improve to make the app experience better, even if they're currently fine with it? And so this goes back to simplicity for the collection side and relevance for the viewing side. And so eliciting feedback from your users allows you to improve your app significantly. And so when we elicit feedback from our users, our approach is we send out a general form that has a few short questions, and then we use that to further and to create more detailed conversations in the future. And so we can, by doing this, we are able to, we encourage them to think outside the box. We think, if you could change one thing, what would you do? Or like, if you could do anything to the app, how could it be improved? And so this shifts from a focus of on the complaints or shortcomings of the app to focusing on how could we do it better, and goes back to our mindset of how can we continually improve. Another thing we haven't done in the past, although we're definitely looking to do it next year, is reevaluating our data fields after each competition. And so I mentioned earlier that we were collecting all these different types of intake data, and we didn't end up using it. And so what we should have done is, in our debrief, we should have reevaluated our data fields. Which ones did we actually use? Which ones are the most useful? And then we could have gotten rid of that intake location to simplify our app and lead us to more accurate data. And also, scouting less, not as useful data allows you to scout more potentially useful data. And so we really recommend, after each competition, reevaluating the data that you scouted, the usefulness of that data, and what data you don't actually need. And that's something we're planning on doing for the coming season. In addition to that, debriefs are a great way to look at UI improvements. And so I mentioned this earlier when eliciting feedback from users. But how can you change your UI to display data in a more useful format, or to collect data in a simpler format? And so those are the main questions we ask ourselves after we debrief from each competition. Another lesson we learned is having a centralized schema. And so schema is basically the data fields you're collecting and the structure of how you're collecting that data. And so what we found is when you have multiple people working on different apps, you need to keep everyone updated with the same set of data points. And so the data points you're scouting often changes constantly when you get new input from your strategy team, or you realize, oh, oh, we could have calculated this data, or we should calculate this, or we should be scouting for this. And so you're constantly updating what data points you're scouting, which we call our schema. And so you need to make sure everyone stays updated on what those data points are and that they integrate those data points into their apps. And so we have facilitated channels for communication to make sure everyone stays updated. In addition to that, we also regularly check our database for incorrect schema, like misspellings or misproper places in the location. And so in past years, before 2018, we had problems with, at competition, that the data would be sent to the wrong place or it would be sent with a misspelling. And so our apps couldn't interface together. And so we implemented a bot that messages our entire team, and it checks the database for any sort of discrepancy or misspelling. And so while you don't need to do something as complicated as creating a script to do this all for you, it's really important to at least check the database for incorrect data points and then inform people of those so that you can fix those before competition. Because if your schema is incorrect, your apps can't communicate together, and then your whole entire system fails just because of some incorrect database structure. Another lesson we learned was to not be afraid to completely start over. And so now we've completely redone our entire scouting system twice. Once I mentioned with the data system earlier in the last year, and we've also completely redone our scouting system before. And so while it's often daunting to give up all the code that you've worked on and start over completely from new, we found that it can give you great leaps in your scouting system and can give you huge advantages if you're willing to, give up on the code that you worked on and then start over completely new because you found a better way to do it. And so while it's really hard to do that, it can provide you a huge leaps in the ability of your scouting system. And so I mentioned this earlier, how we did this with our scouting system for the last year, for the data transfer system. And so we started with the Bluetooth internet sharing. We weren't happy and we wanted to improve. And so we scrapped it. We ended up scrapping it twice and completely starting over. So thank you all for listening to our presentation. We're gonna open up to questions in a second. Before we do, if you're interested in learning more, especially about the technical aspects of our system, that's all documented in our white paper. All of our white papers are available at our website, citruscircuits.org/scouting. And so you can download the white paper, and it goes into specific technical details. It also includes a list of all the data points we scouted. Additionally, all of our code is available on GitHub at github.com/frc1678. It has each of our repositories for each of our different apps. And our code is open source, so you're free to look at it, modify it, or use it for your own systems. And then something we really value is we really want to help teams create better electronic scouting systems. And so we mentioned earlier that we've worked with 1619 and 3005, and we've worked with a handful of other teams. And so we're really open if you want to approach us at competition or you want to send us an email at frc1678@gmail.com. Please approach us. We really want to work with you to create the best scouting system possible. And we're really here because we want to help you create, we want to raise the level of electronic scouting systems. And that's one of the reasons why we open source our code. That's one of the reasons why we open source our code. We really want to help you create the best scouting system possible. Okay, are there any questions? Yeah.
Go to the next slide, by the way, too.
It's
the QR code. So we would like you to take a shot of this QR code. It will take you to a website. There's a survey that will that you can answer questions about what you felt about this workshop, things that you liked about it, things you didn't like about it. So please go there and check it out. And we'll leave this up. You can grab that QR code. Okay.
All right. Question in the back there. Yeah, it's a great question. And so we actually have a slide about that. So basically, we take our data points have really long names. And so in order to compress this, we replace each of our data points with a letter. And so basically, this is what a compressed format looks like. This is a string that goes into the QR code. And so each of these data points is replaced with a letter and then a value. And so this allows us to compress our data significantly, which allows us to create a QR code. You can see here, this example reduced our size for one of our match data, which is a pretty large match data, from 2,035 bytes to 505 bytes. And so previously, we weren't able to fit in a QR code. But now we're able to fit in a QR code. And then we can also use higher levels of error correction. And so if you don't know, error correction on QR code If you increase it, you can cover up parts of the QR code. You can have glare on the QR code. And so you don't have to scan all of the QR code. And so if you have a lower amount of data because it's more compressed, you can increase that error correction level to make the QR code faster to scan and work in environments like competition where you have glare on the screen.
So we were ready for that question.
Yeah. Yeah, so we have a pit scouting app that collects information and images. And then that's all available in the white paper. Yeah.
Couldn't you just have an app that's like say that web app that's on the phone and just use it in the phone immediately, and then use cellular instead of having to transfer from the iPad to the phone?
Well, so I mentioned earlier how having one hardware for your tablets has a great advantage, and also the greater screen size allows you to easily more scout data. And so we had to have the QR code system to transfer data between the tablet and the phone of the scout. Yeah.
Yeah. Oh, one other thing just to say about it, you can use a phone can cover multiple tablets. So it's not one phone to one tablet. So not every scout has to have a smartphone. They all have a tablet, and then scouts can actually share a phone in order to upload the QR data.
Can't you just have like a tablet with a SIM card though?
No,
Yeah,
no,
you
it's
can,
very expensive.
But tablets with SIM cards cost more money than tablets that don't have SIM card slots. And it also costs a lot more money to pay for a monthly connection to each of those tablets, as opposed to leveraging the data connection that most of your users already have on their phone.
Yeah, it's really expensive.
Yeah.
So you mentioned that you record the times at which they perform different actions.
Yeah.
What do you use that for?
So last year we didn't really use it as much to our advantage. We only started the time when they started to line up for a switch or scale placement. And so we didn't end up using the time as much. What we could have done is we could have started the time at the beginning of the cycle when they intaked, and then when they placed it to calculate an average cycle time, which is something that 1619 did, and that's something we're doing with our recoded system.
Yeah, and then we did use timing, for example, on number of cubes into the scale, how quickly they got at how many cubes they got in with 100 seconds left. The other one we did was cubes into the vault. We timed that so that we would, as soon as they started lining up to put cubes in the vault, we clicked that, and then when they got to 8 or 9 cubes, then we clicked that at the end. So those were the 2 big time metrics that we used this year.
Yeah.
What kind of data do you guys collect in this?
So that's all available in the white paper. We collect images, we collect their drivetrain and whatnot, and then all those data points are again listed in the white paper. Yeah. Our scouting app is an Android because Android devices are cheaper and is cheaper to develop for. And then our viewing apps are both Android and iOS native. And then our pit scouting apps are, again, Android and iOS.
Yeah, you can get tablets for $50 a piece. So we found, we just went out and bought a lot of tablets and did not have to put a lot of money into it. So.
Yeah.
You guys use for the backend service?
So we use a Python server, and that runs on a laptop that we bring to competition. And so that's responsible for all the calculations and communicating between the different apps.
And that communicates by cell. So we have a plug-in cell. We typically use 2 cell services, 2 different providers, because we found that you go to an arena and one cell service won't work there, but the other one will. So we found that out the hard way one time in St. Louis.
Are there any other questions? All right. Thank you guys all for coming. And then if you have any more questions.
And thank you for participating.
If you have any more questions, please feel free to let us know. Email us or come up to us at competition. We're more than happy to answer any of your questions.